So my presentation today will be on black holes, and what I'll be covering is basically general knowledge of what a black hole is, how they were discovered, how they were developed, and what they are. So here's a little bit of background. Using Newton's laws in the late 1790s, John Michell of England and Pierre Laplace of France independently suggested the existence of an invisible star. Michell and Laplace calculated the mass and size, which is now called the event horizon. And in 1967, John Wheeler, an American theoretical physicist, applied the term black hole to these collapsed objects. Now we have, what are they? Up here I have the most simple definition is that they are what remains after a massive star dies. Black holes are a region of space having a gravitational field so intense that no matter of radiation can escape. That includes light. A star dies when it uses up all of its fuel. The core then compresses, heats up, and creates a giant supernova. What remains after this huge event is a super compressed core with an incredibly strong gravitational pull. When were black holes formed? Scientists think the smallest black holes formed when the universe began, back billions and billions of years. Stellar black holes, most commonly found, are made when the center of a very large star falls in itself after running out of fuel, like we talked about in the last slide. Scientists think supermassive black holes, which are the largest version of black holes, were made at the same time the galaxy they're in were. Now we have how big are black holes. They can be both big and small. There really isn't a size range. Scientists suspect that black holes the size of an atom can have the same mass as a large mountain. The largest black holes are called supermassive. These black holes have masses more than 100 suns together. Now we have a very commonly asked question, why are black holes black? This is because a black hole cannot be seen because strong gravity pulls all the light into the middle of the black hole. Scientists can study stars to see if they're flying around or orbiting a black hole. When a black hole and a star are close together, high energy light is made. This kind of light cannot be seen by human eyes. Basically, just pull all the light into the core because its gravitational pull is stronger than the speed of light or light itself. Nothing can escape. Here we have another commonly asked question, but one that shouldn't be taken as seriously, and that's, could a black hole destroy Earth? Black holes do not go around space eating planets and stars. That's just a myth. Earth will not fall into a black hole because there isn't one close enough. There's not one even near our solar system, so it's not theoretically possible. Here we have the parts of a black hole. Over here is our schematic. So we have ring singularity, the center, the collapsed core. That can be as small as an atom or very large, has a very dense mass. We have the event horizon. Here we have both outer and inner. It's the opening of the hole. At this point, there is no escaping. You cannot escape a black hole once you've passed the event horizon. Here's the ergosphere, an egg-shaped region of distorted space caused by spinning of a black hole, which causes it to drag surrounding space. That, I think, is just cool because the gravity and the force of the black hole is so strong that it drags space along with it. And there we have the static limit. It's the boundary between ergosphere and the outer space, so it's kind of like a safe zone. Now, how do we detect black holes? There are 3 different ways. You can find the mass, the gravity, or the radiation. With mass, many black holes have objects around them, and by looking at the behavior of objects, you can detect the presence of a black hole. You can then use measurements of the movement of objects around a suspected black hole to calculate the black hole's mass. Then there's gravity. An object with immense gravity, like a galaxy or a black hole between the Earth and a distant object, could bend the light from the distant object into a focus, much like a lens can. And now, when the Hubble Space Telescope looked at the object, it saw 2 images of the object close together, which indicated a gravitational lens effect. The intervening object was unseen. Therefore, it was concluded that a black hole had passed between Earth and the object. Then there's radiation. When material falls into a black hole from a companion star, it gets heated into millions of degrees Kelvin and accelerated. The superheated materials emit X-rays, which can be detected by X-ray telescopes such as the orbiting Chandra X-ray Observatory. Lastly, here are my sources cited. I hope you enjoyed the presentation, that you learned something useful, and I hope you have a good day.